Very good morning to all of you. Myself, Mr. Mahbudur Rahman, Assistant Professor in the Department of Food Engineering. Today, I will cover the first law of thermodynamics. So, first of all, see that what is the first law of thermodynamics. First law of thermodynamics, it is based on the law of conservation of energy, which states that energy cannot be created or destroyed, but it can be transferred from one form to the another form. So, it is the first law of thermodynamics. Now, according to the statement, the change in internal energy of a system, it is equal to the heat added to the system minus the work done by the system. Delta U, it is equal to heat added, that is Q minus W. Change in internal energy is equal to heat added to the system minus work done by the system. Now, enthalpy for quantities, it is called as thermodynamic potentials, and that are useful in the chemical thermodynamics of the reaction and non-cyclic process. They are internal energy and the enthalpy, the Helmholtz free energy and the Gibbs free energy. Enthalpy is defined by H is equal to U plus PV, where P and V, they are the pressure and the volume, and U is the internal energy. Enthalpy is the precisely and measurable state variable, since it is defined in terms of three other precisely definable state variable, and it is some parallel to the first law of thermodynamics for a constant pressure system. So Q is equal to delta U plus P into delta V, since in this case Q is equal to delta H, where P and V are the pressure and the volume, and U is the internal energy enthalpy. It is then precisely measurable, and according to the first law, for a constant pressure system, Q is equal to delta U plus P into delta V. So it is useful quantity for tracking chemical reaction. If as a result of an exothermic reaction, some energy is released to a system and it has to show up in some measurable form in terms of the state variable. An increase in the enthalpy H is equal to U plus PV, that might be associated with an system work. When work is done by the thermodynamic system, it is usually a gas that is doing the work, and the work done by the gas at constant pressure is W is equal to P into delta V. For non-constant pressure, the work can be visualized as the area under the pressure volume curve, which represent the process taking place, and the most general expression for work done, that is integration of P into dV. Integration limit is V1 to V2. Okay, thank you for watching. Once again, thank you.